In this video, we're going to learn how to divide a polynomial by another polynomial. And one example is this: divide 15x squared plus 7x minus 4 by 3x minus 1. Well, we're going to explain a general method for doing this. And to think about what we're supposed to get, we're looking for a polynomial that when you multiply it by 3x minus 1 gives you 15x squared plus 7x minus 4. Well, first of all, what degree should the polynomial have? Should it be degree 3? Should it be degree 4? It should be degree 1, right? Because if I have 3x minus 1 and I multiply it by some polynomial and I get 15x squared plus 7x minus 4, when I multiply by a polynomial, let's say I arrange the polynomial so that it goes from highest degree terms to lowest degree terms. I'm multiplying 3x by something, and that should give me a 15x squared. So I know that I should have a degree 1 polynomial. In general, the degrees will add when you multiply two polynomials. So if I take a degree 1 polynomial and multiply it by a degree 1 polynomial, I will get a degree 2 polynomial. So I know my polynomial has degree 1. So that means it's some constant times x plus another constant. And I'm trying to figure out what constants will work. Okay. Well, since I'm trying to illustrate the strategy, let's distribute the 3x minus 1 across. So I'm going to get 3x minus 1 times some constant times x plus 3x minus 1 times some constant equals 15x squared plus 7x minus 4. And I want to know what the two constants are that will go in the blanks. Well, if you think about it, okay, let's try to figure out what this constant is going to be. Notice that if I look at this term, 3x minus 1 times some constant, I'm never going to get 15x squared. How come? Because if I take 3x minus 1 times a constant, I'm just going to get a constant times x minus another constant, right? I'm not going to get an x squared out of it because this blank has no x's in it. So I'm going to get a 15x squared from the 3x minus 1 times something x. Now, what constant do I need so that when I multiply, I get 15x squared? I have to multiply by 5x, because if I take 15x squared and divide by 3x, I get 5x. So I know that I need a 5 there. So let's write down what we have. 3x minus 1 times 5x plus 3x minus 1 times a blank equals 15x squared plus 7x minus 4. Now I'm going to distribute this and then subtract it on both sides. Well, 3x minus 1 times 5x is 15x squared minus 5x. Let's subtract that from both sides. That will give me 3x minus 1 times something equals 15x squared plus 7x minus 4 minus 15x squared minus 5x. And what I get is 12x minus 4. So 3x minus 1 times what equals 12x minus 4? What goes in that blank? It's going to be 4. So now I'm done. I know what goes in the blank. It's 5 and 4. And so the answer is 3x minus 1 times 5x plus 4 equals 15x squared plus 7x minus 4. And you can check by multiplying that it is in fact correct. Let's reorganize the process. Well, first of all, let's go over what the process was. The process was we figured out what the degree of the polynomial that we're looking for is. And then we use our reasoning to figure out what the first constant has to be. We saw that it has to be 5 because we need the 3 and the 5 to multiply to 15. And then once you figured out that the first number is 5, then we were able to figure out what this term was. You subtract it on both sides, and then you get a next blank, this one. 3x minus 1 times blank is 12x minus 4, and then we were able to figure out what goes in the blank. So one way to organize what we did is to do this. Take the polynomial 15x squared plus 7x minus 4. We're dividing that by 3x minus 1. Now remember how we found the 5? We thought about what do you have to multiply 3x by to get 15x squared? Well, it was 5x. And then what we did was we multiplied 3x minus 1 by 5x. 3x minus 1 times 5x. And then we subtracted that from 15x squared plus 7x minus 4. So I'm going to write down 3x minus 1 times 5x below 15x squared minus 5x. And then we subtracted it. And that gave us 12x minus 4. And now we see what you have to multiply 3x by. We repeat the process. We see what you have to multiply 3x by to get 12x. That's 4. So it's plus 4 times 3x minus 1 equals 12x minus 4. When you subtract, you get 0. And that gave us the quotient on the top, 5x plus 4. That's exactly what we had here. So the answer is 5x plus 4. The reason I wanted to do this first example where we did it out like this is because I wanted to show you that this is the process that we're actually doing. We're figuring out what constants go in the blank by this systematic procedure of figuring out the first number, then multiplying the 3x minus 1 across, and then subtracting, and then repeating again with the next number. And we just keep going until we get to the end. That's what leads us to this division algorithm that I illustrated below. Let's do another example. Divide 4x squared minus 7x plus 3 by 2x plus 3. Okay, we're going to use the division algorithm to divide the polynomials. Well, first of all, I notice, this is a 4x cubed. Okay, 4x cubed minus 7x plus 3. Well, I notice that there's no x squared term. Right? What I really have is 4x cubed plus 0x squared minus 7x plus 3. And let's insert that as a placeholder. So 4x cubed plus 0x squared minus 7x plus 3. Why are we doing this? The reason we're doing this is because if you don't, things will not line up properly when you do the multiplication. And you can probably see why if you try doing it. So we're dividing this by 2x plus 3. And let's go over the steps again. We divide the first term, 4x minus 3, by the first term of the divisor, 2x plus 3. So in this case, we're doing 4x cubed divided by 2x is 2x squared. So we put a 2x squared here. Then you multiply the divisor by 2x squared. So if you take 2x plus 3 times 2x squared, that is 4x cubed plus 6x squared. 4x cubed plus 6x squared. And then we subtract, because we're trying to see what we're left with. And now you see the benefit of having the 0x squared on the top. So that way, you don't have a minus 7x and then a 6x squared. So we have the x squareds lined up. So what we end up getting is negative 6x squared. and then minus 7x plus 3. That's what we get when we subtract. And now we repeat the process. We take negative 6x squared and divide it by 2x, and that gives us negative 3x. Then you multiply that by the divisor. So 2x plus 3 times negative 3x gives us negative 6x squared minus 9x. And then we subtract, and we get negative 7x plus 9x is 2x plus, and then you have the plus 3 still. And now we know what the last term is. We divide 2x, this first term here, by the 2x here, we get 1. So plus 1, that gives us 2x plus 3, and then when you subtract, you get 0. So since you ended up getting 0, okay, that tells you that 2x plus 3, when you multiply it by 2x squared minus 3x plus 1, gives you 4x cubed plus 0x squared minus 7x plus 3 exactly. Okay. So the answer was 2x squared minus 3x plus 1. Let's do an example where you get a remainder. So divide 10x squared plus x to the 4th minus 5x cubed minus 10 minus 4x by x squared minus 2x. Well, first of all, I noticed that the polynomial that I'm writing, the first one, it is a polynomial, it's just not written with the terms in descending degree. And in order for the division to work properly, you want to make sure that you write the polynomial with terms in descending degree. By the way, the thing that you're dividing is called the dividend. So rewrite the dividend with terms in descending degree first. So then you're going to get x to the 4th power minus 5x cubed plus 10x squared minus 4x minus 10. And now we divide by x squared minus 2x. Okay, so we repeat the process. You should try doing it and see what you get. Okay, let's see what we get. So you have an x squared here, because x squared times x squared is x to the 4th, and then you multiply x to the 4th minus 2x cubed. Then you subtract, then you get negative 5 plus 2 makes negative 3x cubed, and then you bring down the rest of the terms, because that's what you have left. Now, we do the same thing. So you get negative 3x, and then negative 3x cubed plus 6x squared. You subtract 4x squared minus 4x minus 10, and then plus 4. So then you get 4x squared minus 8x. Subtract negative 4 plus 8 is 4x minus 10. Now here, there's no more part of the polynomial I can multiply by x squared minus 2x to get 4x minus 10, because the degree, 4x minus 10, the degree of 4x minus 10 is 1. That is less than the degree of the divisor of x squared minus 2x, right? The thing I'm dividing by has a bigger degree than what I get. So when I have something like that, that is the remainder. It's just the part that I have left over. So what I found is that if you do x squared minus 2x, and then you multiply by x squared minus 3x plus 4, okay, I almost get the original polynomial, the dividend. I almost get that, but I have to add a 4x minus 10 to get the original polynomial, to get x to the fourth power minus 5x cubed plus 10x squared minus 4x minus 10. Right? Because this thing that I got, if you subtract it from the dividend, you get 4x minus 10 as a remainder. So therefore, when you take this product and then add 4x minus 10, you have to get the original polynomial. Well, we've written it like this, but the question was, what do you get when you take the dividend and divide by the divisor? Well, let's take this equation we found and divide both sides by x squared minus 2x. Because that's what we're looking for. We were looking for x to the fourth minus 5x cubed plus 10x squared minus 4x minus 10 divided by x squared minus 2x. Now I have a polynomial divided by a polynomial. I can split this fraction into x squared minus 2x times x squared minus 3x plus 4 over x squared minus 2x plus 4x minus 10 over x squared minus 2x. Right? I'm just splitting up this thing, because I have a plus here. I'm just splitting it up into the sum of the fractions. And now I have on this first term on the right, I have a factor of x squared minus 2x and a factor of x squared minus 2x on the top and bottom. So those cancel out to 1. Okay. So I'm left with x squared minus 3x plus 4 plus 4x minus 10 over x squared minus 2x. And that is the answer. And you can check that it's correct if you if you take this equation and then distribute this product across and then add 4x minus 10, you do in fact get the dividend. So let's review what we did. First of all, I started off with a simple example of taking a quadratic polynomial and dividing by a linear polynomial. And the reasoning was we knew we have a degree 1 polynomial. We figured out what the first constant was, the coefficient of x, and then we subtracted on both sides and then kept going until we got to the end. And then I explained that there's a way to keep track of what you're doing by doing this division algorithm, where you multiply and subtract and multiply and subtract. It's the exact same steps if you think about it as what we did above. And the reason I explained the thing above instead of just jumping to the algorithm, the step-by-step procedure, is because I wanted to show why this works. Right? But once you understand why it works, you can kind of just do it. So here we did an example of a cubic polynomial divided by a linear polynomial, and we noticed that when you have a 0 as a coefficient, like in this example, the coefficient of x over 0, you want to make sure that you put in a 0 x squared. So you want to make sure that you always have a coefficient for every possible term. So that way things line up when you do the division. And then we did an example that illustrated that you want to make sure that your polynomials are in descending order in terms of degree before you do the division, and then sometimes you get a remainder. And once you get a remainder, okay, you can get a remainder, that's totally fine. You divide you rewrite the polynomial as a product plus the remainder. Right? And the remainder, by definition, will have degree less than the degree of the divisor. So in this case, 4x minus 1, always, the 4x minus 10, the remainder has degree less than the degree of the divisor, x squared minus 2x. That's the divisor. Okay. And if you divide both sides by the divisor and simplify, you end up getting this expression. And that's the answer. You could also have jumped straight to this as the answer, but I wanted to explain where that comes from. Okay, so that's how you divide a polynomial by a polynomial.